Uh, Good evening, sir. I am Mathiharan, and my friend Sriram is there. So our topic is directing access to unauthorized areas using facial recognition for our biometrics project. So we're gonna do our review 1 and 2 right now. So let's move to next slide. So if you let's see a quick wrap of our project in abstract. So as we see recently, we have seen like there is an huge number of facial recognition applications are in industry. So this has gone in a higher way because there are a lot of buildings which need to restrict the access for many unauthorized people, or else we can call them as an intruder here. So they need to restrict those people from entering inside. So for such kind of applications, we are going to use facial recognition, which can make the system to automatically stop them from entering inside the restricted areas. And so such kind of people may, if they are allowed inside, they may cause some serious chaos, right? So we're gonna use this system to restrict them. So our system is nothing but we are using the facial recognition biometric system to detect those faces who are trying to enter into those areas. If they are familiar with the system, then they will be allowed inside. If not, an unfamiliar, unknown faces detected by the facial recognition system of ours, then we will be sending an alert message to the owner of the system, or also owner of the building, either or else the security guard which who is in charge of the situation right there. So we will be sending an email or else an pop-up notification will be sent to them. So once they receive the sound on the notification, and they will be alert, and then they will take the appropriate actions whichever required to deal with the situation there. So that's the abstract of our project. Moving on to the introduction, as we know, surveillance is an key of every security system in a building, or else in every organization. So the other basic thing which they require is a strong physical security, such as we have seen like many security guards are there in VAT. Also, we have a lot of security. So we need a physical security as well as the biometric. In VAT, we have a fingerprint security, right? So similarly, for preventing unauthorized access, we are going to use facial recognition. So this both will go hand to hand. So both of them will be handy for each of them. To enhance the physical security system, we need our face recognition system to add a higher level of security layer to the environment. So what we're going to do is this will make the job of the physical security is easy. So if we use a normal camera, then to detect the faces, and then each security has to keep on checking 24 hours, and then it will be a hectic problem for them. But our system will enable them to, it will automatically detect the unknown faces and then give pop-up notification, which will make their work quite easy. Not quite easy, it will be a lot of easiness for them. So that's the goal of our project. We'll be blocking those unauthorized access automatically. So the remaining will be taken care of by the physical securities. Move to the next slide. So coming to the physical applications of the project, I have seen told you like we are in VAT also we are using. So similarly, the other secure areas like military base are one of the most secure area which need to be surveillanced throughout the days. A military base, because it's an national duty, right? So there will be if you see borders, we have a lot of problems going on right now. So for such kind of areas, we can apply our facial recognition detection system. So it will prevent those unauthorized access into the military bases. And then even for normal houses, nowadays they are applying this facial recognition system outside. So the camera will automatically detect, and then it will give notification to the house owner automatically. And then for research labs such as some secrets, some if I can say like ISRO is conducting secret research programs, or else NASA is conducting some secret research programs which it doesn't want the outsiders to know about them. So for such kind of places, it need to maintain and manage the surveillance right through the day. For such kind of areas, we can apply this, and then for similarly for police stations to keep track of intruders who is going out and keep coming in, right? So for these areas we can use, and then the most important is a nuclear power plant, right? Like we have seen in Chernobyl, some unknown person entered and it's totally in history now. So to prevent such massive kind of incidents, we can use this. Yeah, moving to Sriram. Sriram will continue.
Yeah, this I saw this is Sriram. Let me proceed with why we chose facial recognition system and other biometric systems fail in this category. So first the iris systems. As we know, iris systems are a bit costly, and if they are used in locations like offices and homes, they're too costly to install and cannot be installed in multiple locations. And investment in iris systems is a big challenge here. And distance is also another factor because iris recognition can be accurate when the distance between the person and the scanner is like 25 to 30 centimeters or 50 centimeter like that. But in the reality, when an intruder enters, he won't be so close to the system, and he may even try to sneak in. So iris systems won't be possible here. And fingerprint cannot be, obviously cannot do the job. As the intruder, when he's trying to intrude into the place, he's not going to use any fingerprint. To, he's not going to use any fingerprint, and then, as he's already entering without permission, and it's not going to do the job. And voice systems again fail as the intruder is already sneaking into the area and he doesn't want to make any noise and do some unauthorized job. So it's not going to make any noise, and voice systems they're not going to help us. Signature biometrics, as we know, signatures can be easily forged, so that signature biometrics cannot also help in this area. Now let's see the challenges of the system. As we seen all the advantages of the facial recognition system, still our system has a few challenges which we need to address. And first is the accuracy of the system. When it comes to accuracy, this is a big challenge because some categorizing the faces particularly is a big challenge. And next, coming to the facial recognition system, it's actually, as we know, it's a bit complex in case of implementation because it comes to large areas like military bases and offices. There are a lot of people inside the location. So feeding every enrolled faces onto the system is a bit hectic job. So implementation it's a bit difficult, but it's the right one for. The camera is another challenge because some cameras they based on the investment perspective. If we see some people will use thermal imaging camera, some people will use infrared camera, some people use a basic surveillance camera if they don't need to spend much. So each camera will give a different accuracy result, and so the results will be affected when it comes to using cameras. So camera is another challenge. Then recognizing faces in dark place also is a challenge, another challenge. Then illumination, and intruders sometimes would cover their faces or would disguise themselves, which would make facial recognition task which a bit more and more hectic and challenging. Then this is, usually we have seen in even on a theory part, they see the facial recognition process. First, the face tracking and detection takes place, and then after the detection, the face is aligned such that the location is taken, and the size of the face and the pose is taken. If the pose is a frontal or side view or anything like that, and then comes the feature extraction. From the aligned face, all of the features related to a particular face are extracted, and then they're fed onto the database, and then and those features are matched then the actual detection takes place, and then we will see the face ID match results if the result is successful or not. Now, in our project, this is the general process in application. First, we supply the positive negative images of a person who is allowed in an area. and again we supply the same positive and negative person who is not allowed in any area. But this is a bit hectic because the sizes, if the application is used in offices, there are a lot of people in there, so feeding every feeding user, feeding the images of every user is going to be very problematic. So, but however, if the application is small, this is it's going to help us. So positive and negative images of a person is not allowed or not allowed, we are going to supply those images. Then we are going to use those images to train the machine learning, use the machine learning models to train those images. Then we will use appropriate devices to recognize those faces and alert the designated person if the person is an unauthorized person. Mayan will continue this.
Yeah, so let's keep our first step to the implementation. So what we require is we need an Python version which is above 3.6 version, or else very recently there is an upgrade is available there, so we can use that. And then we need an web camera, or else to be specific, it's also fine to if we use an facial recognition camera. And then we need an account in SendGrid, and then yeah, API key ID to send email alert to the if any intrusion is detected. So the third point will be seen in review 3. So moving further, next slide. So these are the packages and libraries which we'll be using for our implementation part. OpenCV is nothing but this will enable us to process the images, and then it will enable the computer vision task. And then Immutales is we will use this to plot MATLAB libraries images. It will make us plotting easier. And then facial recognition is also an package which is inbuilt in Python. This will recognize and manipulate faces, like like it will automatically detect the faces. And then SendGrid is another Python package we will be using in review 3. And then Python.nv is also a package which will be used to manage the environmental variables of the Python programming. Yeah. So in the implementation procedure we are using is actually it's quite a big process. First we have to set up the Python environmental variables, and then next is we are whatever the packages and libraries which we have seen in the previous slide, we are going to install those in our Python files. And then we are going to create a directory where we will be storing our facial enrollments of each of the members who need access to the database system. So Sriram, can you please go to the directory?
Okay, one second.
So if you see, this is the directory which we are going to create for each of the individuals who need access to the database system. So since it's an privacy concerned restricted area, we will be quite having a few quite like numbered. We can just count the number of people who need access, right? So that's what we call as a restricted area. So here since we are only 2 members, we have kept like only 1 member in the directory. So we have just captured the images of such persons in different angles. Go back to the PPT, please. Yeah. Yeah. Moving back to the previous slide. Okay. So no. Yeah. Next, back. So we have seen the folder, right? So next is we are having an enrollment Python file. So we are going to use that. We will be running that Python file to capture the different angles of an individual, and then we will be storing those different angle captured images into that folder of each individuals. Then we will be running another Python file which will encode those images, each individual images using an CNN. CNN model is nothing but a convolution neural network model. So we are using that model in that Python file. And then the last is like pickle file is nothing but it will just convert those matched key and individuals images which will be stored in a Python dictionary. So each of those values will be converted into bitstream character streams. So that's why pickle is used. So we are just converting those into character streams and then storing it as a pickle file at the end of this process. Next is second part of the process. So now, after those part one is completed, we will be just testing the CNN model by running the Python code. So next, we use the HCM model, HAR cascade model. It's nothing but it will enable us to detect the image, detect the face of an individual in on video or running video, runtime video, or else an image. It would automatically detect the number of faces it's available in an image. So that's why we are using a hard cascade model. And then the video on detection is broken down into smaller cascades. Why? Because each image has a large number of faces. Like for example, if a group photo has some 4 or 5 members, so we need to detect each one's faces and properly, right? So that's why we are dividing those into smaller cascades, and then we are using frontal face detector to detect those faces. Finally, once the system find the persons who are already stored in the database, then it will allow the person to enter inside. Or else, if not, it finds an intruder, then it will send us a notification using via mail or else on a pop-up notification to the owner of the system. So that's how this implementation procedure completely works. So next, Sriram will continue.
Uh, Let me just we are just seeing the few screenshots of the implementation where I have enrolled my face and already through the Python code, and this is a few code snippets, and this is the detection. Let me now get to the actual code. This application actually there are three codes we have implemented in this. The three codes are three different purposes. First is the headshots Python file. This is a file which actually captures all the features of the face and all the detection all the enrollment and feeds them onto the directory. So here this is the first. If we explain the code, this is the .rb1 is the folder name we will be giving to store the images. Through video capture, uh, we will be capturing the faces of the individual who will be entering in the camera or in the webcam. And here from the each we will be reading each frame in the camera, and if for every second we need to take photos of the person so that we can all the photos are stored in the and each photo will be in a different angle and different pose. So we will press space to take a photo, and we will be doing that using every using this logic. Every key pressed in the keyboard has a specific value. So using that value, we will calculate the value, and if escape is pressed, the application will quit. And if space is pressed, it will keep on capturing the images of the uh, enrolled the user to be enrolled. And all the after the capturing, when we are done, we can just exit, and all the images will be stored through the hex string, which is through a package called UUID. This is a unique random ID generator used to generate from a random hex string. And after we will release the camera, and we will all destroy all the windows. Madhiran will proceed with the encode phases.
So as we have already said, like we are going to use an encode Python file to encode the images, each individual images. So can you go at the, yeah. So if you see at the top, we have already imported all the packages which you have mentioned earlier. So image path is a variable where you will be seeking the data set of an individual's path, and then and then we are going to just initialize the to list which is known encodings and the known names. As of now, there is as per the system, there is no person is detected right now. So we are keeping it as a blank list, and then after going further, we are going to use an for loop. So once the image path is detected, we are just moving file by file. So that's what why we are using so each iteration will move to each individual images of the single person. So it will just extract the person's name from the image path. We have mentioned an variable name equal to image path that split. So that will just extract the person's name from the directory's path. Then each individual will be read using the cv2.im read below. So that will just process the image and then store the individual images into the image variable. Then we are going to use cvt color. It's nothing but we are just converting the BGR model to RGB model, and then we are just storing that to RGB variable. Finally, the box which will detect the image, we are using face recognition inbuilt package. So we are using that package to locate the face of each individuals in the image. So we are using the model HOG, which you have seen earlier. So that will just detect using the boxes, and then it will automatically calculate the n number of boxes which is detected in the single image. So once all this is done, we are just going to proceeding with the encoding part. So we are using face recognition dot face encoding, which is also in an inbuilt package. So once we encode this image boxes and then images as an RGB model, we are again going to just paste. Once encoding is done for each individual image, we are just going to like string concatenate to another list, which is already we have mentioned as a blank list right at the beginning. We have mentioned the known codings as a blank list, and then known names also as a blank list. So yeah, here. So once we have encoded, we are creating an for loop, and then we are just saving those encoded variables values into those lists. And then finally what we are just taking these two lists, and then we are just creating an link between these two lists as per the name of the file and the name of the persons. So once we link this, we are just showing it as an data is nothing but an dictionary file, dictionary variable. Sorry. So we are after the dictionary variables written, we are just going to create a file. A pickle file is created, encodings.pickle file is created. We are just keeping it as an writing mode. Once the file is open this and in a writing mode, we are just writing the data which is a dictionary file into the pickle file. So as I have already told you, like pickle is nothing but we are just changing those dictionary files or those list files into an string of characters. So all these values will be stored as a string of characters in the pickle file. So finally, after writing the file, we are just closing it. Yeah. So moving to next Python file. So
Yeah. So now this is actually the detection code which we will be doing when the individual comes into the camera. Here the charts are encoded faces.py we have already implemented, and that is where we got this. And the charts.py is the code we was talking about, and here we have captured all my faces in different angles and different poses, and through specs and without spectacles, so that the system would be give accurate results. And all those after storing all those images, as Mathiharan said, from the directory, every facial feature will be extracted and stored in this encodings.pickle file. And now comes the actual detection part. We'll import all the required libraries, IM utils to create on the video stream and FPS to capture the frames per second and all the face recognition models and pickle and time. Now let's as we discussed, we are using the as air cascade frontal face classifier model. So which will be usually used to detect objects in the scene. And next, we just displaying all the encodings, and we are just loading the pickle file which we have already created, and also the cascade classifier. And next, we are using the video stream to start the video stream, and for every 2 seconds, we'll be capturing the frames, and we will be starting the we will be starting to capture the frames per second. All this comes in a loop because till we exit out of the code, exit out of the application, the application will be capturing frames at the regular intervals and detecting the faces which will be in the which will be in the frame or in the camera. So this is the code actually we will be doing. The code will be reading the frames every second, and will convert them into the 500 width or 500 width cascades, and the and the everything will be converted into the color codes will be converted from the to gray color model, and the one and here RGB will be converted to BGR to RGB. Then comes the detector. This is the actual detection. It will be the scale factor is used, and the minimum neighbors are the other minimum neighbors and minimum size is used. And the boxes is the one is used where when the capturing the faces, the images alone will be shown in boxes, so that only the faces will be shown in the detection, and not other pictures will be disabled. So we'll be running through the encoding part, and we will just find the results. If the matches is there, or we will matches is there, it will be written the name of the person who is entering, or we were, or the application will show the unknown person is entering the card. So finally, we'll stop the FPS process and we'll exit out of the application. Now let me run the system so that you will get a better idea of it.
So here we are just going to detect the face of the individual using a webcam, which is available for us right now.
Yes, sir. I just faced an error because we are actually running a video now through the Zoom app, recording this. That's why the two processes cannot happen at the same time. Let me just turn off my camera and try this again. See that we can see that it detects my face perfectly, and we'll be doing it for multiple phases in the coming reviews. And we'll be sending an email alert if email alert if someone unauthorized enters the frame, enters into the webcam, or enters into the facial recognition camera, so that the authorized person will take appropriate actions. Just let me quit this application.
It would have been better if we are in college, because right now we don't have much people to interact to show the project review of n number of people's faces. So that's why we are showing only single member face.
Yeah.
So
Yes.
so that's it from review 2. Just go to the PPT and complete. Yeah, continues. Yeah.
Yeah. For review 3, we will be doing this 3 parts, sir. Actually, we will be detecting a bit more accuracy. Sometimes we will see some the unknown classifiers, or actually not unknown classifiers. There will be boxes will be coming with unknown faces. So we just have to reduce the detection. We already faced that issue, and we have reduced the problem, and it was a bit more accurate. As we have seen in the video, you didn't see any other yellow boxes around the image, and send email alerts will be done in review 3, so that if people enter in the camera, people's uh, when they enter the camera or the frame, the email will be sent to the authorized person, so that they can take any appropriate actions. And last, the testing a few more different places if we can, so that it will be a bit more realistic. That's
Yeah. Thank you for more questions. Thanks.